10, 9, ignition sequence starts. 6, 5, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower clear.
Plus 30 seconds.
11, 10, 9, 8. Ignition sequence has started. 6, 5, 4, 3, 2, 1, 0. We have commit and we have liftoff at 2:13. The Saturn V building up to 7.6 million pounds of thrust, and it has cleared the tower.
Mission control. Here we go.
It's a beauty. It's another beauty.
No, I think it's a dynamic on flight. The projector looks good. They show a 1.5 mile altitude at this time. 13 Houston, go at 30 seconds. All completed and we're pitching.
Autopilot enabled. T-minus 10.
Oh my gosh.
9,
Let's
8,
go.
7, 6, 5, 4.
Oh yeah! Yes! Let's go!
All 7 engines at full thrust.
Yes!
Pressures are good. Vehicles cleared the tower. Now passing 18 seconds into flight.
Let's go, new
Engine two
plane!
pressures look good.
10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 1. And liftoff of United Launch Alliance Vulcan rocket carrying USSF 106 from the United States Space Force, continuing ULA's soaring legacy in national security space launch with the innovative Vulcan rocket.
Thrust. Half mile and altitude. Complete our pitch and yaw program. Body rates turn 0. Fuse down to closed loop control.
Ten, 9, ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running.
And this This has new importance as the revamped plan for Artemis 4 uses...
Welcome in, everybody. Well, welcome in, and I know it's a little bit early, but we're here to watch SpaceX's launch of Falcon Heavy, transporting the Nancy Grace Roman telescope. SpaceX's broadcast is already in progress. Sorry, I'm tired. I didn't get much sleep. And we'll just tune in and see what they're talking about. We're still about 30 minutes away from launch, 29 or 25. And here we go. If you have any questions, put them in chat and I'll try to answer them.
And live TV works. So, but I can only see that, right? I can't even tell that Dominic is next to me if you weren't talking, Dominic.
I'm over here, Megan. But I can only see your face, and I can't see anything else around you at all.
And so what we're going to do is mimic this focused field of view for you guys at home. See, so all of a sudden we're gone, right? All you can actually see is the top of our desk. But again, open it up. We're going to open up our glasses that we have on our faces here. Look at what widening the view does. Now I can see Dominic. Hello there.
Hello. Here we are again.
We can see the desk.
See everything.
Yeah, exactly. We can see our props here. We can see our laptops. So explain now how that relates to Roman, why widening out our view is so incredible.
Megan, we're able to get a big picture, and by that I mean the quality is in the quantity of data. Rather than looking at one object and understanding it, we want to understand the host of objects, understand the big picture of the universe writ large.
And also, you know, I've heard Dr. Julie McHenry say this all the time, you know, our universe is such a dynamic place that it's so hard to capture it all at once, but actually Roman will allow us to capture more.
Well, there are objects in the universe that are changing all the time, every second. Stars and galaxies that you have to know to look at. But we have a wide field of view, so we'll be looking at millions of them all at once and understanding them in an entirety.
Wide, but still very detailed. How do we accomplish that?
We had to make a camera that was able to achieve the same kind of detail, sharpness of image that you get with the Hubble Space Telescope, but with a much wider field of view that allows us to capture all those celestial objects. We could only do this because technology has allowed us to make the largest infrared detector in the world.
This.
Indeed. And so I'm going to start by saying, well, everybody knows what a camera is like because they have one in their pocket every day, in their cell phone. Everybody's cell phone camera has a detector. That's the part, Megan, that turns light into electronic signals that we then interpret as the actual image.
Okay.
I have here a very small detector for a modern cell phone camera. It's a 12 megapixel sensor. And the actuality of the sensor is this tiny little black square in the middle,
right there.
That little bit is the optically active part that turns light into signals. That little part is everything that we have to make all the beautiful images that you can take with your cell phone. Now, Roman has to do that job over a much wider field of view. I'm going to hand this to you, Megan, and just compare it to the entirety of the Roman focal plane. That detector that you see there is 300 million pixels, and the pixels are larger, so they gather ever more light. They are able to see objects halfway across the universe because we have all that same detail that you'd expect, but so much more information than we've ever been able to acquire before.
Sure. Cell phone camera, Roman. Incredible.
Exactly.
And actually, thinking about it in that way, then when Roman takes its images, I mean, at full resolution, these images will be ginormous.
The smallest Roman images will be 1 billion pixels.
Oh my
When
gosh.
we take 1 billion pixel image, there isn't a screen on Earth large enough to display all of that at once. And that's a small image. The largest Roman images will be 1 trillion pixels. If you wanted to view that on 4K monitors, you would need 500,000 of them tiling 45 city blocks to have a single large Roman image encapsulated at once.
So then how do you study an image that large? Are you going to buy all those 4K cameras and lay it out in Central Park?
Megan, I don't think we have a budget for that many monitors necessarily. But we do have a lot of people, interested astronomers and citizen scientists around the world who would love to have access to this data and can help identify interesting objects and can help machine learning to train computers how to do this so that computers can do this for us.
Great, 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 great. Technology really advancing what we can do in the scientific
Okay.
community.
It's on the cutting edge of what is possible today.
Perfect. Okay, we're getting new updates on fueling, so let's head back to Steve and Jared.
Thank you, Megan. We are looking good this morning. We are at T-minus 20 minutes, 45 seconds. Fueling continues. We are about 80% on the first stage boosters when it comes to fueling, about 70% or so with the oxygen. And we do have stage 2 fuel load complete with that call. Jared, we're continuing to move toward an on-time liftoff.
Yeah, once again, it's still been very clean on the boards. No warnings or alarms or anything coming up. Always happy to see that. LOX load should start here in maybe a minute and a half or so at 18:30, and then that'll be. We'll also hear call-outs for completion of RP1 load and LOX load a little bit later as well for the boosters.
And we've been watching, of course, the rocket loading to boost the Roman Space Telescope. The spacecraft itself was fueled completely some time ago.
Yeah, probably about a month ago or so. Roman was filled with what they call hydrazine. It's a hypergolic fuel. They use that in their thrusters to what we would call station keeping around that L2 point, about 1 million miles away from Earth.
And when you think of a satellite out in space, out at that Lagrange 2 point, hydrazine comes in handy just to kind of station keep in that orbit, as I understand it.
Yeah, that's right. It's for probably at what I would say is like the larger movements of the spacecraft itself. But when you want to get down to really pointing precisely to get those nice still pictures and gather all that light from deep space, you really need to use the spacecraft's gyroscopes, or reaction wheels is what they would refer them to. Those are there to make the very smooth, very precise pointing adjustments to really look into deep space and get that clear imagery of the cosmos.
Excellent, excellent. So we are T-minus 18 minutes, 57 seconds. All the systems are looking good. Weather continues to trend positive. We remain 70% go. And looks like things on the Space Coast are working towards the Roman Space Telescope's favor this morning. And with that, we'll go back up a few miles near Launch Complex 39A for Megan and Dominic.
Stage
Hello
2,
there.
LOX load has started.
LOX load starting here as you are looking at our iconic countdown clock. 18 minutes, 22 seconds until liftoff. Right in front of them, a crowd of people there. Oh, they have signs. Again, just a sampling of all the people who are here for there they go, they got their cue.
Oh, I love it, I love it.
A sampling of all the people here who are on the Space Coast in Florida here for today's launch. Really excited again, as we just heard, that fueling continues with LOX loading, liquid oxygen loading into the vehicle. Again, here we are for Roman's launch. Just as, again, a wonderful day. You were saying before that this is 20 years in the making for you.
It's been a long time getting here, Megan, and it's thrilling to see so many people in the crowd here, so many who want to see this, who are just as thrilled about it as I am.
And so Roman could change literally everything we know about our universe.
Roman was designed to address key questions that people have asked for a very long time.
Mm-hmm.
One of them is about exoplanets and whether there are planets out there and solar systems out there like our own.
Mm-hmm.
That situates our place in the universe.
Of course, yeah.
The other is about the biggest questions on the grandest scales, the fabric of the universe, how the universe that we see around us came to be, pushed and pulled by the competing forces of dark matter and dark energy. These are mysteries that Roman was designed to settle, and I cannot wait to see this launch so that we get those answers.
And how do you study mysteries like that with two impressive instruments, right?
We did build Roman with two fabulous instruments. One of them is the wide field instrument, and we have the iconic camera with our logo right there. The second is the coronagraph instrument, perhaps the most complex instrument and capable instrument of its kind that can measure the reflected light of planets around other stars.
And so the coronagraph, this is a smaller model. Obviously, the larger one, as you said, is closer to the size of a baby grand piano. Actually, the detector here, this is the actual size. So just really cool to have these visually here for us.
Yes, that is the actual size of the detector. Of course, it's in a camera. That's
Tigger came by to say hi.
Oh, my gosh. Okay, so speaking of the coronagraph, NASA Jet Propulsion Laboratory in California led the design, construction, and testing of it. Leah is back this time with Jason Rhodes, a cosmologist at JPL.
Good morning, Megan, and good morning, Jason. Thanks so much for joining us all the way from JPL. It's great to have you with us today. So this isn't the first coronagraph that is actually launching into space, but it is the most powerful. How so?
Well, the Roman coronagraph will be about 100 to 1,000 times more powerful than any coronagraph flown in space. And this is because the Roman coronagraph is going to use a number of new technologies debuted together for the first time in space. These include technologies like single photon counting detectors. When you're blocking about 100 million or 1 billion photons from the very bright star for every single photon you get from the planet, each of those planet photons is precious and we want to capture it. Another of these technologies is these small deformable mirrors, about this big, and these deformable mirrors have about 2,000 pistons over the mirrors that allow us to change the shape of the mirror. And by changing the shape of the mirror, we're able to correct small imperfections in the telescope or the optics to put the starlight away so that we're only capturing the planet light on the detector. And we're going to do great science with these new technologies on Roman, but the real goal is to test them out for possible future use on a future coronagraph that would use these to look for signs of life around planets outside of our solar system.
So
One of the most technologically advanced telescopes that we've ever launched.
So when you get those first images back, what are you hoping to see?
Well, the first thing we hope to see when we use the coronagraph is essentially nothing at all. If the coronagraph is working correctly and we point it at a bright star, we're not going to see any of the star's light, and that means it's working. So we're going to be excited to see essentially nothing at all. But really, then what we want to do is we want to move the coronagraph from that bright star that we're using to calibrate it to a bright star that has a known planet. And while the Roman coronagraph won't be able to look at planets as small as Earth around sun-like stars, it will allow us to take the first images of a planet like Jupiter around a sun-like star in reflected light. And that is going to be an amazing science opportunity, but it's a huge step forward in developing these technologies that are going to be used on a future coronagraph to look for signs of life around exoplanets. So it's within my professional career to be able to search for life outside of our solar system.
Great, Jason, thank you so much for being here today. And Megan, we're going to send it back to you.
Thank you to you both. Now, Roman will take its pictures from a special spot in space called the Sun-Earth Lagrange Point 2, or L2, and it is way farther from the farther than the moon is from Earth. It's actually 4 times farther. Why there?
Well, it's about 1 million miles away, so that from its vantage point, the sun, the moon, and the Earth, which are bright and hot objects, are all to one side, and we keep our solar arrays so that that makes shadow where we are and where the telescope is, and so we have a relatively unobstructed deep space view of the darkest sky. We can be very efficient in our observations because there isn't a bright star or a bright planet in the way.
Okay, gotcha. And then it actually won't be alone there. We have Webb at L2.
For the same reasons, the James Webb Space Telescope was also sent out there. But you don't have to worry. Even though L2 is a point, neither observatory goes just there. They actually do an orbit around that point. And that orbit is larger than the moon's orbit around the Earth. So they're very far apart from each other. It's totally safe.
Okay, perfect. But we did get some questions about that, so we did want to address it. All right, so then, Dominic, when can we expect to see Roman's first images?
So when we send Roman out there 1 million miles away, it will take about 3 months to get out to that point, during which time we are turning on the instruments, aligning the telescope, calibrating everything so that we are ready to begin efficient observations as soon as we're there. So we anticipate being able to do that towards the end of the year, and then we will release first light images in early 2027. All of the Roman data go public right away, Megan. We will be processing it as quickly as we can. Almost 1.5 terabytes of new imagery every day, going live to the entire world as soon as we can take it.
Wow.
All these images are going to be public.
Exciting for a lot of people, again,
so
across the world who are interested in
astronomers across the world
so I think it's a
can
great
look at
to
it.
Also tell people about Roman's Adopt a Pixel
Amateurs
campaign.
too.
We're announcing this campaign for the first time on this broadcast.
And kind of an open source project.
1 Roman image pixels. So we are inviting you to sign up for one of those pixels by visiting nasa.gov/adoptapixel. Imagine that, Dominic, your own piece of the sky.
Yes, and everybody can have their piece of the sky and see what's there.
And so this mission, again, named after Nancy Grace Roman. In 1960, she became NASA's first chief astronomer and the agency's first woman to hold an executive position. She championed putting telescopes in space, which paved the way for missions like today.
The first encouragement I got was in my junior year at college, when the head of the physics department came up to me in lab one day and said, "You know, I usually try to talk women out of going into physics, but I think maybe you might make it. So pick something that you want to do." In my case, I wanted to do astronomy, and I'm very glad that I did.
And we're very glad that she did.
10 minutes out.
Okay, 10 minutes, 18 seconds and counting until NASA's Nancy Grace Roman Space Telescope launches. We have time now for a question from our live audience, actually. Remember that group we showed you earlier today? They were holding signs and everything like that. One of them actually sent in a question.
Great.
So let's read that question
What
now.
have they asked us?
This is Nicholas Venuti, and he wanted to know, Roman is named after Nancy Grace Roman, as we said, who believed in the Hubble telescope before anyone else. So that being said, if she could witness launch today, what do you think she would be most excited about?
Astronomy has moved on such a lot since she first conceived of the Hubble Space Telescope. We didn't know about exoplanets. We didn't know about distant black holes. We didn't know about dark energy. All these things are new. And I think what she might be most excited about, and perhaps what I'm most excited about, is that when we take these wide-field panoramic images of the universe, we will be seeing areas of space that have never been seen before. We'll be seeing the far side of our galaxy in detail for the very first time. What new things will we discover that we don't even conceive of at the moment?
Sure.
What questions will Roman answer that we don't even know how to formulate yet?
Yeah.
That's what's going to make this mission transformative and a civilization-scale experiment.
Absolutely. I completely agree with you. That's what I'm most excited about. Again, some of those questions that we don't even know to ask. So, okay, let's take another look at the clock here. We are 8 minutes, 52 seconds and counting. Dominic, we've talked about this before. In 5 years' time, what do you hope we learn from Roman?
Well, with Roman, we know we're going to answer some of these questions, the fundamental ones. Are we alone? Is there a planet like the Earth out there? What is the fabric of space and time made of from dark matter and dark energy? We're going to get those answers in that sort of first 5-year survey. But we're going to have so much additional data that we're going to make available to everybody. And my greatest hope is that everybody worldwide engages in this data, helps us learn from it, helps us understand it, helps us analyze it, helps us make discoveries far beyond anything I could ever have imagined when we got started on this.
So Dominic, let's get Roman to launch. You just heard that call out for RP1 loading completion. So let's take you guys to the final moments of the launch countdown with Steve and Jared here at Kennedy and Zach and Hawthorne.
Thanks, Megan. We're getting into those final minutes before launch, and it's definitely getting exciting. Now, coming up shortly, we should be hearing a call out for booster engine chill in just about 40 seconds or so. And that means that the 27 M1D engines on the center core and side boosters will be undergoing chill-in with locks ahead of launch. Now, liquid oxygen on board Falcon Heavy is chilled to over 300 degrees below zero and is flown at a low flow rate through the engine plumbing and piping prior to ignition to prevent thermal shock and boil off when the ultra cold liquid starts moving at high flow rate during launch. And as we have been loading these chilled propellants, both LOX and RP1, the temperature of the aluminum tanks has started to drop considerably, and that's what's leading to those white clouds that we can see coming off the rocket. Those clouds and vapor are from the warm, humid Florida air coming into contact with the really cold walls of the rocket, but is entirely normal and is just like when you see your breath on a cold winter day.
Engine chill has started.
And there's that call out that engine chill has started. And coming up in less than a minute, we'll hear the call out that Falcon is switching over to internal power. And this means that we're disconnecting our external ground electrical supplies from the rocket, and it'll then be entirely running on its own onboard batteries. Now, up to this point, power has been routed to Falcon via the transporter erector.
NY fuel load complete.
The transporter erector, or TE, that you see there next to the rocket, and that TE does a lot of heavy lifting as it rolls our Falcon Heavy rocket out to the pad, raises it vertical, and stays connected to the rocket through the final seconds before launch. The TE also provides fuel, power, telemetry, and command connections between ground systems and the vehicle.
And we are 6 minutes from the launch of NASA's Roman Space Telescope atop a SpaceX Falcon Heavy rocket, fueling going well this morning, both on the boosters and on the central core stage, as well as stage 2. Oxidizer load also still underway on stage 2. And Jared, we can see some of that venting that Zachary was just explaining there into the Florida sun.
Yeah, that's for sure. Definitely lots of cold liquid oxygen on that rocket, and we've had plenty of rain here lately in Florida. Luckily, looks like the weather is clear, as you can see. We're still green on the range as far as weather is concerned, and the weather radar looks pretty good. So I'm thinking that we shouldn't be constrained by the weather today, this morning. So that'll be great.
And launch specialists like yourself, you kind of enjoy this this silence that we're hearing on the nets this morning, because really means they're not discussing any technical issues. The callouts that we're hearing are the usual ones that we
Falcon
would
Heavy
expect.
tanks are pressing for strong back retract.
Yeah, that's for sure. And yeah, we just paused there for strong back retract call. That Falcon Heavy is getting pressurized, and so that you're pretty much getting up to your flight pressures, make sure that the vehicle's nice and sturdy. As Zach mentioned before, that TE, or the transporter erector, rolls the Falcon Heavy out from the pad and then takes it vertical. But a little bit later here, in just maybe 15 seconds or so, you'll see the clamp arms up near the top. They'll actually pull away from the top just below the fairing there.
Strong back retract has started.
And then we just heard the call out for strong back retract starting, which is great. That's pretty much just, it'll recline a few degrees just to get out of the way for when Falcon Heavy lights, and hopefully goes off to space here in 4.5 minutes.
And as the launch pad machinery gets ready into its launch positions, we are expecting the NASA side, the NASA launch manager, to conduct.
NLM, it's LD looking for the NASA status check.
Yeah.
This is NLM. NASA's go for launch.
Good words there from the NASA launch manager. Go for launch this morning. We are at T-minus 3 minutes 45 seconds for heading toward an on-time liftoff just after 7:26 a.m. of NASA's Roman Space Telescope.
Yeah, that NLM poll is a really important one. That's the NASA launch manager, like you said, giving SpaceX launch director the go that the NASA team is ready. Behind the scenes, the NLM would have gone and polled his engineering team, the spacecraft team, safety and mission assurance, everybody on the NASA side, to make sure that everybody is green and everything's looking healthy, which is great. And then, as you heard, he is go for launch. So we are go for launch for NASA.
PY lock sled complete.
And we have, as the rocket continues to put its final propellant on board,
And white lock sled complete.
We also know that the spacecraft sitting on top of the nose there, that's heading into space, that is on internal power. So it is running off its own batteries. Of course, it's covered up by the fairing, but it can run on those batteries for a little
Stage
bit
1 lock sled complete.
before it has to pick up some of the sun's energy.
Yep, that's for sure. And we just heard on the loops, LOX load is complete for stage 1, which is a great sign.
So we're going to go back to Hawthorne and Zach for the last 2.5 minutes before launch.
Yeah, thanks, Steve. So coming up in just about 20 seconds from now, we should be hearing the call out for stage 2 LOX loading completion. And at that point, the Falcon Heavy will then be fully loaded with nearly 3 million pounds of propellant comprised of RP1 and LOX. So we should be hearing that call out for
Stage 2 LOX load complete.
And there's that call out right on time. Now, coming up shortly, we'll be hearing a call out for closing out of gaseous systems, called out as ground gas closeouts, and that'll consist of topping off tanks and sealing vents in order to maintain pressure in the vehicle. And we should be hearing that call out in just about 15 seconds or so. And weather, of course, is now looking beautiful there in Florida. And we're right on track for launch in just about 1.5 minutes from now.
Ground gas closeouts.
And there's that call out for ground gas closeouts. Now looking ahead at the T-minus 1 minute mark, Falcon Heavy will enter startup and the onboard flight computers will take over the launch countdown and both stages will begin pressurizing for launch. So we should be hearing that startup call in just a few moments.
Falcon Heavy is in startup.
And there it is. Falcon Heavy is now in startup, and those flight computers are in control of the count. So we're now just waiting on the final go, no-go from the launch director for today's mission.
The launch director is go for launch.
And great news there. The launch director has given the final go for today's mission. So let's sit back and watch as Falcon Heavy takes the Nancy Grace Roman Space Telescope to space.
T-minus 30 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon Heavy and go Roman Space Telescope.
And liftoff of NASA's Roman Space Telescope on a mission to revolutionize our understanding of the universe.
All three boosters firing.
Pressures are nominal.
Falcon Heavy has cleared the tower and is on its way to space.
This is the same as a Falcon 9. It just has two more first stages bolted to it.
Steve, great shot there from on top of the rocket, looking down, and then now tracking up, looking at those 27 Merlin engines, lifting the Falcon Heavy and Roman Space Telescope off into space.
Falcon Heavy soaring.
Power and telemetry nominal.
Falcon Heavy soaring into the Florida sky. We are 53 seconds into this flight. Rocket will be heading into max Q.
Falcon 9 is supersonic.
Picking up speed and altitude very quickly. Engines will throttle down slightly to reduce the mechanical pressure and the mechanical stress on the rocket.
Max Q.
And we heard that call out for max Q, which is the point of maximum aerodynamic pressure as the rocket is ascending. Now, coming up in just under a minute from now, we're going to have a large series of events happening back-to-back. We'll be starting with BECO, or booster engine cutoff, where the engines on those boosters will power down. We'll then have side core separation of those two boosters. Followed by that, we will then have MECO of the main core, and then stage separation of that, as well as second engine start one following that. Now, those two boosters will be heading back to Florida today. They'll be doing boost back burns to put them on trajectories back towards Kennedy in Florida. Now, we should be hearing that call out for BECO in just about 13 seconds from now.
Love how those plumes expand as you get up there in the atmosphere.
Side booster separation confirmed.
Oh.
And there we saw stage separation, and you can actually see the view from the main core on the left, and then the two side cores on the right-hand side of your screen.
PY boost back startup. NY boost back startup.
And there's confirmation of the boost back startup on those two side core boosters. So at this point, both Falcon Heavy side boosters are performing their boost back burns, which is the first of 3 burns each side booster will undergo on the way back to Cape Canaveral Space Force Station. Now, the primary objective of the boost back burn is to quickly reorient the side boosters onto the required return trajectories, and this is required in the event of a return to a launch site as opposed to a drone ship ocean recovery. And today they're headed towards landing zones 2 and 40 in Florida. Now, meanwhile, in the center core, the 9 M1D engines are continuing to power Falcon Heavy on its nominal trajectory. Now, the engines on that center core are still burning right now. They're set to burn for about another 12 seconds or so, and then they'll throttle down, and we'll have our MECO, our main engine cutoff of that, and then we'll have stage separation of this center core and the second stage shortly thereafter.
PY boost back shutdown.
NY boost back shutdown.
PICO.
Stage separation confirmed.
And great shot there as the first, main core and second stage separate from one another. And we just heard that call out for second engine startup. And you can see the MVAC engine there on your screen with a beautiful view of Earth behind it.
Bearing separation confirmed.
And we also just heard confirmation of fairing separation. As I said earlier, those fairing halves are no longer needed. And you can see one there on your screen.
And 4 minutes, 38 seconds into the mission, Roman Space Telescope gets its first taste of space. Payload fairings jettisoned.
All vehicles are following nominal trajectories.
And we are coming up on an expected AOS, or acquisition of signal, important step. Really just getting spacecraft's just sending its pulse over the NASA systems.
Yeah, that's right. The acquisition of signal should hopefully be coming up here in a minute or so. That'll be the first opportunity that the spacecraft can go and quote-unquote talk to the ground station, the folks back at Goddard, to make sure that it's still happy and healthy on the way during the stage 2 boost burn. But everything's looking good as far as telemetry is concerned for MVAC. You can see there the nozzle extension glowing orange as it's going around the Earth.
Launch of the Roman Space Telescope looking very good as the Falcon Heavy carries the observatory into orbit. Of course, the Roman telescope won't really open its eyes, so to speak.
Stage 1 FTS is saved.
Until later in the mission, when it gets out to that Lagrange 2 point about 1 million miles from Earth. Everything that we're seeing.
No images today from the telescope.
PY entry burn startup.
Be about a month before it gets out there, and I think they said the first published images should be in January.
Moment for the spacecraft team.
That's for sure.
PY entry burn shutdown.
Yeah, Steve, so we just had
entry burn shutdown.
We just had the entry burns on those side core boosters as they're making their way back to Earth right now. Now, as mentioned earlier, we will be attempting to recover both side boosters, which are targeting a landing at landing zone 40 and a landing at landing zone 2 at Cape Canaveral Space Force Station. And you can actually follow the vehicle telemetry
PY FTS is saved.
of those side boosters via the telemetry on your screen there.
NY FTS is saved.
PY transonic.
Now, we're just waiting for those landing burns to start up in just about 10 seconds from now.
Stage 2 FTS is saved.
PY landing burn.
NY landing burn.
Stage 2 is in terminal guidance. PY landing leg deploy.
NY landing leg deploy.
PY landing confirmed.
NY landing confirmed.
And we've got a beautiful shot of one of those side core boosters there on your screen. We did, of course, have confirmation of successful landings of both of those side core boosters, and certainly most people in the vicinity heard those sonic booms. Now, coming up next, we are expecting the shutdown of the second stage MVAC engine, and this is known as Second Engine Cutoff 1 or SECO 1. And we should be hearing that call out here shortly, and afterwards we'll just be waiting for confirmation of good orbit.
Nominal orbit insertion.
And there's that call out for nominal orbital insertion after we turned off the MVAC engine on the second stage there. So coming up next, we have a bit of a breather coming up before the next milestone for the mission, SES-2, when the MVAC engine on the second stage restarts as it continues to its orbital destination. So let's hop back over to Megan and Dominic at the Kennedy Space Center in Florida. How did that launch look, guys?
Amazing. Almost didn't make it back here.
Oh.
We went outside to
cannot
watch
express
it. It was great.
In some ways, I could never believe that this moment would actually happen, and it is
Aw.
here and far more beautiful than I could have anticipated.
Yeah, how
Megan,
does it
I'm
feel?
so glad that we've done this.
Oh, I'm so glad. Thank you so much
you for
what
sharing it with
you
me.
and the. Oh yeah, no, thank you for sharing it with us. Again, what you guys and the team have developed here is amazing.
We built this in order to provide emotionally impactful and scientifically impactful imagery for all of humanity, and I feel like we have managed to achieve that today.
And now it is up in space, on its way there. Let's actually take another look at that launch, just in case you missed it. It was just 10 minutes ago from here at Kennedy Space Center.
1, ignition, and liftoff. Go Falcon Heavy and go Roman Space Telescope.
This is a replay, of course.
Again, NASA is hoping
Vehicle is
this
pitching
mission
downrange.
will help answer some of the biggest mysteries in the universe, and in order to do that, it has to go more than 1 million miles away to a place called Lagrange Point 2, or L2. When could we start seeing data from Roman, Dominic, to start answering some of those ambitious questions you talked about?
Well, Roman is on its way, but 1 million miles is a long distance.
It
It'll
is.
take about 3 months for Roman to get out there. We'll be turning it on and commissioning the observatory as a whole so that when we get there, we can begin taking operational observations right away. And those data will start to become available and public around early 2027, and we'll be releasing them every day as we process the data
I can't
from then
wait.
on.
Can you wait just a couple more months?
We can wait a couple more months because we've got a heavy load of work to turn this instrument on and make it as amazing as it was designed to be.
Absolutely. And so again, a lot to unpack about this mission. If you have any questions about anything that we're talking about, send them our way by tagging @NASA anywhere where you're watching this broadcast. Okay, Roman is a flagship mission, as we've been saying, for NASA Science. With our Leah Martin now is Nikki Fox, an Associate Administrator for NASA's Science Mission Directorate, and Sean DeMoggle-Goldman, NASA's Astrophysics Division Director.
Hi, Megan. Like you said, I'm joined here by Nikki and Sean, and I have to say I was able to watch your faces right after that mission launch. I don't think I have ever seen two people more excited probably to see a spacecraft lift off. So congratulations, first of all, to the both of you. Extraordinary launch, extraordinary being able to see your reaction.
Sorry, Mama keeps pawing my leg.
You saw both of us crying downstairs, but yes.
Incredible moment.
Got food.
Nikki, we've talked a lot about the incredible volume of information that this mission is going to be able to give us. How is that going to bring us a little bit closer to answering those profound questions we have in humanity? Are we alone? Are there other universes like this? Are we correct in what we know about our own universe?
Absolutely. I mean, Roman is going to revolutionize the way we look at our universe. It is going to measure dark matter, which is, I know that sounds bizarre, but it's like the fabric of the universe. It's the thing you can't see, but we know it's there. It's going to measure dark energy, which kind of powers the universe. And they have that sort of a cosmic struggle between dark matter that wants to pull things together and dark energy that wants to push things apart. And that will allow us to finally kind of explain our universe and understand our place in it. Not only that, it's going to find a whole ton, like, tens of thousands of exoplanets, planets that we don't even know are there, billions of galaxies, tens of billions of stars. It's just a spectacular mission.
Oh my goodness, it's so poetic the way you lay it out like that. And Sean, for you, this is just one of many telescopes that we actually have in the NASA fleet. Tell us, how does this work together with the other instruments that we have in space to be able to get a better picture of the universe in which we live?
So thank you. The best way I could describe that is, imagine you're taking pictures of a forest. You want to get pictures of not just the forest and the trees, but the birds on the leaves and on the branches of those trees. We have special telescopes like Hubble and James Webb that zoom in and take pictures of those birds. And we have other telescopes that do the panorama, that get the whole forest. Roman is a superpower because it can do both. It can get the whole forest and then zoom in at the exact same time and count the birds on the branches of those trees. And when you think about it, like once you're doing that, you're doing ecology, except these aren't birds and trees and forests. We're counting up supernovae and galaxies so we can study effectively the ecology of the known universe the way that Nikki just described. So it's an amazing thing, and I'm just
sorry, folks. I keep
for
yawning.
How many human beings put their hands on this thing? Not their literal fingerprints.
About 2 hours past my bedtime. I'm a night person, but sun comes up and I get sleepy.
So much for being here again, and congratulations.
And I haven't had any sleep in the last couple of days, so I'm probably going to sleep for a pretty good while this morning.
Megan, we're going to go back to you.
I am as excited as they are, as well as those folks here right in front of the countdown clock. Again, 14 minutes after launch. Look at them there with their signs, waving, jumping. I love that so much.
Oh, yes.
Again, so much excitement around this launch again, because it could just discover so much we don't know about our own universe. So again, we've been taking some of your great questions live throughout the show, so we have time for more now. Why don't we pull up the first one on our screen here? What other things will Roman be able to observe besides dark energy, dark matter, and exoplanets?
Oh, Megan, that goes to right what we were just saying about Roman. It has such amazing potential for discovery. One of Roman's surveys will be to look out into our own Milky Way galaxy. Looking at the plane of our galaxy, we can see with Roman's infrared vision all the way to the center of our galaxy and beyond and through and out the other side. That's a part of our own home galaxy that we have never seen in detail before.
Wow.
We will find tens of billions of stars, young stars, old stars, stars all the way across. It'll be the largest astronomical catalog in the history of astronomy.
Wow, I'm actually getting goosebumps. Look at it, goosebumps as you're talking about it, because again, just to discover so much is so intriguing. All right, let's take another question now.
Yes, what else do we have?
What will the next future telescope be like? Great question.
Well, the Roman coronagraph is designed to test out those new technologies, as we heard about from Dr. Jason Rhodes earlier today. It's a very complex set of new technologies that will block the light of a star so we can see the reflected light of planets orbiting around the star. Roman can see a planet like Jupiter around a star like our sun. The next observatory will have a similar coronagraph that can detect an Earth around a sun-like star.
So smaller and closer. That's really incredible. So for more than 2.5 centuries, America has pushed the boundaries of space exploration, and it continues today with Roman's journey to deep space.
250 years ago, 13 colonies laid the foundation for the greatest and most enduring democracy in the history of the world. One driven by courage, faith, and freedom. From that moment, we became a nation defined not by where we stood, but by how far we were willing to go. We conquered vast frontiers, invented tools that shaped a modern world. We found light in the dark, and we rose from the earth. Faster, higher, farther. We pushed beyond the sky and into the unknown. Today, our curiosity stretches farther than ever. American robots search ancient rivers on Mars. New telescopes unfold to glimpse the first stars. For 250 years, America has carried the light of humanity forward. But American exceptionalism isn't inherited, it's earned. Our greatness comes not only from what we've done, but what we're still determined to discover. Because in every era, across every horizon, America is at its best when it's reaching for something greater. America celebrates 250 years, and we are leading the world into the future.
Now, Now, once operational at L2, Roman will help us study things like dark matter and dark energy. But again, we've been saying they're invisible. So how do you see things like that? Well, Roman will use gravity as a tool, and Dominic's going to explain.
Well, Megan, everything in the universe that has mass has gravity associated with that mass. Gravity bends light, it distorts light, and it therefore distorts images.
Okay.
So when we look out into the universe, past all that dark matter, the gravity of that dark matter distorts the images of the galaxies we see beyond it.
Okay.
And so we can use this as a tool. When we measure the distortions of those galaxies, we can infer the dark matter between us and them. And we can make a three-dimensional map of all of the foam of dark matter that's out there for the first time.
I think I followed you, but you said that there's a visual way to show this.
Let's
for
demonstrate
folks, right? Yes,
this.
thank you. I'm a visual person.
It's a great thing. So since we're going to be ready to celebrate, we have our champagne flutes. The champagne flutes will be our dark matter.
Okay.
They're clear, right? It's
Sure,
invisible.
invisible.
More or less invisible. And our galaxies will be our iconic Roman Space Telescope logo.
Okay.
Now, the pattern of galaxies is a little like the pattern of letters. It's recognizable. You know what letters should look like. But when dark matter intervenes between us and those letters or those galaxies, as we distort the imagery, you can see the word space telescope are distorted by that dark matter.
I see.
And we can make those maps, and we can then see where the dark matter is distorting the distant galaxies and infer where that dark matter is.
Right.
Just like you could figure out the word space telescope and figure out how much glass is in between the camera and this image.
So again, you might not be able to see the dark matter, the dark energy itself, but because it's distorting things behind it, you're like, something's there.
Yes, because dark matter moves the light around, just like dark energy moves things around in space. We don't see them directly, but we see their impact on the universe. And since dark matter and dark energy are 95% of the total matter and energy that's out there, they dominate everything. All the stars, all the galaxies, they are there because dark matter and dark energy have pushed them and pulled them to be there. And we would like to understand how those work, because that gets at the very fabric of our universe. How did the universe come to be the way it is?
Sure, really clever, a clever tool that we're using here. Now, Roman's wide field instrument will use this technique along with other methods to explore our universe on an enormous, unprecedented scale. But why does seeing that much of the sky at once matter? Leah is back with her next guest. Hey, Leah.
Good morning, Megan. Nice to see you again. I'm here joined by Ami Choi, who's actually our wide field instrument scientist here on the Roman mission. Ami, thank you so much for joining us today. So we just saw Amy and Dominic demonstrating how this wide field instrument actually works, but why do we want to map the sky on this scale? What does it actually tell us?
To understand the universe's biggest questions about dark matter, dark energy, and planets beyond our solar system, we need both the finer details and the really big picture. And imagine photographing a landscape, as Sean just mentioned earlier. Instead of just a single tree here or a mountain peak there, we get the whole picture, and those patterns that are revealed can help us put the whole picture together.
And how is this different from other instruments that we have currently in space? We talked a little bit about the different instruments that are on, but how does that are on Roman? But how does this one actually work differently?
Roman combines Hubble's sharpness, but with 100 times the field of view. And so that means we don't lose the finer details, but we can very efficiently map out the sky, like very large volumes of the sky. And we can also point at a new location with Roman and settle down very quickly. And so we spend more time taking pictures than just waiting.
And so with the speed, we'll actually be able to get some more of that data. We'll be able to get more of it quicker and be able to understand and kind of unravel some of those mysteries a little bit faster.
That's right.
So currently we know of about 6,000 exoplanets, but how many more are you guys anticipating that this wide field instrument will reveal?
We're anticipating around 100,000 new previously undiscovered exoplanets, including about 1,000 that will be revealed through microlensing, a specific type of gravitational lensing. And so we will learn a lot about cold, rocky planets and potentially some in the habitable zones of their stars.
Really? Okay, so So you're actually looking, is this going to be used in conjunction maybe with the other Habitable Worlds Observatory that we heard Dr. Fox talking about a little bit earlier?
That's right. And it'll help pave the way for habitable worlds.
Fantastic. Ami, thank you so much for joining us today. And Megan and Dominic, we're going to send it back to you.
Thank you so much, guys. Another look at the crowd there. 23 minutes after launch, and they're still so excited to be here as we continue to follow along as the Falcon Heavy second stage continues its journey out with Roman. So let's head back to SpaceX for that next operational milestone.
Thanks, Megan. Now, just to recap everything that's happened so far, we had an on-time liftoff of Falcon Heavy from historic Launch Complex 39A in Florida at 7:26 a.m. Eastern Time. A few minutes after that, we jettisoned the two side cores, with the center core jettisoned shortly after. And those two side core boosters performed boost back burns and made their way back to Florida for landings at Landing Zone 2 and Landing Zone 40. And you can see those there on your screen, Landing Zone 40 on the left and Landing Zone 2 on the right. And the second stage performed the first of two burns, which lasted about 4.5 minutes. Next major milestone coming up in just under 30 seconds from now will be the second engine light on that MVAC. That burn is set to last for about 2 minutes and will be the second and final burn of those two burns needed to send the Roman Space Telescope on its way to the Sun-Earth L2 point. Now, as mentioned earlier, L2 is the Lagrange point on the opposite side of Earth from the Sun, which is approximately 4 times farther from Earth than the Moon. So we should be hearing that call out for SES-2 momentarily.
Oof. And maybe we're not going to see any more images. We may not, because this is much higher than the SpaceX Starlink satellites.
The graphics that we have at the bottom of your screen there. The engine that is currently firing
Welcome
is
in,
the
Xbox.
vacuum or MVAC engine located on the second stage. Now, this engine has a much larger nozzle than the sea-level M1D engines located at the bottoms of the 3 boosters that made up the first stage. Now, we unfortunately don't have views of that engine burning right now. Now, that extended nozzle allows for optimal performance of this engine when operating in the vacuum of space where there's no atmosphere to burn in. Each M1D engine can produce a max thrust of about 190,000 pounds of force at sea level, whereas this MVAC engine can output about 220,500 pounds of thrust in vacuum. Now, we've still got about 30 seconds left of this MVAC engine burn. Taking a look ahead in the mission, about 5 minutes after the conclusion of this burn, we will then have payload deployment of the Roman Space Telescope, and that deployment is set for the T+31 minute and 31 second mark. And we should be hearing that call out for SECO-2 in just about 10 seconds from now. And just standing by for that call out of SECO-2.
According to telemetry, they already did it.
Nominal orbit insertion.
And there we heard that call out for a nominal orbital insertion. And with
It's
that,
in
we've still
orbit.
got one more major event coming up, which is the most important one, and that is, of course, payload deployment of the Nancy Grace Roman Space Telescope in just under 5 minutes. How are things looking over at Kennedy, Megan?
Hey, Zach, it's looking really good over here. It's exciting to see that we're nearly there, and we can't wait to see the live images of Roman's deployment into space. Now, we just told you about Roman's Wide Field Instrument, the mission's primary science instrument, but Roman has a second instrument, and that is its coronagraph, a technology demonstration designed and built by NASA Jet Propulsion Laboratory to test how we can block the bright glare of a star to see the much fainter planets orbiting around it. So Dominic, that could eventually help future telescopes, we were talking about this before, maybe find other planets like
Okay,
Hubble
Xbox.
and some like ours.
That's just YouTube and Twitch.
This is an extraordinarily
they
challenging
don't send out
problem. You saw
alerts
in that
like they
little
used
video
to.
there, the planet being lost in the glare of the light of a star. A planet like Jupiter.
Twitch has had a lot of
is
problems
10
lately
million
anyway.
times fainter than the star that it's around.
Wow.
A planet like the Earth is 1/10 billionth
Oh my
as bright
gosh.
as the star. So you have to block that starlight exquisitely. The Roman coronagraph demonstrates all the technologies necessary to do this for the very first time in space.
Wow.
And a future telescope, the Habitable Worlds Observatory, will then carry that forward to measure the light of an Earth-like planet around a sun-like star, look at its atmosphere, and tell us whether there are.
This was so early, I'm not going to get a whole lot of live views, but
Again, just always advancing.
maybe people will come back and watch it later.
Pushing the boundaries of capability and knowledge.
I love that.
Every day.
All right, we are now just a few minutes away from Roman separating from the Falcon Heavy second stage. Our broadcast will end shortly after that, but you can keep learning more about this mission here.
And so will mine.
Get ready for NASA's new view of the universe and the Nancy Grace Roman Space Telescope with a special limited series of NASA's Curious Universe.
So you're asking for the 10-second description of how the universe entirely works.
We're building one-of-a-kind satellites. It's never been built before. No one's going to build this again.
Want to go deeper? Find the story behind Roman at nasa.gov/podcasts or wherever you get your podcasts.
The idea of pulling back the curtain on so much of the universe that we still don't know yet is super intriguing, not just for scientists, but also artists too, like singer-songwriter Jewel.
It's Jewel, and as you may know, I make artwork using astrophysical data. And
Yeah,
maybe
Twitch is
nothing
slipping.
more fascinating than dark energy and dark matter. And so it is with this great wish of great success and Godspeed that I wish the Nancy Grace Roman Space Telescope. So exciting.
We're expecting Roman to soon separate from the Falcon Heavy's second stage, so let's watch that moment unfold with Steve and Jared.
Thanks, Megan. We are about a minute and a half away from that expected separation of the Roman Space Telescope from the Falcon Heavy's second stage that has gotten it into orbit and on its way to the Lagrange 2 point. Jared, exciting morning so far?
So far, so good. Everything's been right down the middle. As far as stage 2, burn 1 and burn 2 have been perfect, and so really, really great so far. Been a great morning.
Like I said earlier, it's going to take over 3 months for
confirmation from the
telescope to
spacecraft
get
itself,
into its orbit
early
out
in the
there.
launch, around 7 minutes or so. First acquisition of signal or pulse from the spacecraft. That was a big milestone as well. As we look for another 30 seconds. Another 30 seconds before that separation comes. Roman is, of course, recharging its batteries on solar power, and looking forward to that flying free on its own.
Yeah, hopefully we'll get a good shot of stage 2 here. They usually have a great forward-looking camera from the top of the stage 2 to see. And there we go. And we have a shot of the.
All right, we are getting live feeds. Good deal.
Right. Let's see if we can see.
Nancy Grace Roman Space Telescope, separation
Beautiful.
confirmed.
There it goes.
There we go. Nancy Grace Roman Space Telescope flying free on its way to Lagrange 2 and to open a new eye on the universe. And of course, a lot of celebration with the team, Jared. I know you represent a lot of people in NASA's Launch Services program, and across NASA, a lot of work goes into this. I hope you have enjoyed it. We've enjoyed having you.
Yeah, it's been great. Yeah, wonderful spacecraft deploy. Hear all the claps here behind us in the mission dress and in the mission control room. I'm sure the same at Goddard. Thanks so much for having me today. And most importantly, congratulations to the whole Roman team on behalf of the Launch Services program. It's been great working with everybody, and we really can't wait to see all the great science that you're going to do out there.
Yeah, it's going to be terrific. Roman is on its way, and we are going back to Zach at Hawthorne, California, and SpaceX.
Thanks, Steve and Jared, and what a spectacular deployment. Of course, a huge thank you from SpaceX to everyone at NASA for the partnership on this mission, and to all of the teams on both sides who brought NASA's Nancy Grace Roman Space Telescope to the pad and into space. Now, with the launch completed and successful deployment from our second stage, that's going to do it for me here in Hawthorne. So I'll hand it back to the NASA team from here. Over to you, Megan.
Hey, thank you to our launch commentators, and yes, to SpaceX as well as NASA's Launch Services Program for getting Roman onto a trajectory towards Lagrange Point 2, or L2. And now the spacecraft teams will take over, so let's hear from Leah with her last guest.
Hi, Megan. I'm actually joined here by Jeremy Perkins, who's part of our science commissioning team. And I have to tell you something that...
Well, hang in there for just a minute more.
Right after launch, and he was showing me on his watch this really interesting pattern of a regular heart rate, then right at 7:26.
Xbox is going out to the Lagrange Point 2, which is actually an orbit out there. Same area as Hubble telescope. It's about 1 million miles out.
So things here are starting to simmer, but it's actually just now picking up for the mission team. What are you guys doing now? What's next on the board?
It'll take it about 3 months to get there, and you can get set up.
I mean, I think I just saw the video of us deploying from the rocket.
And they should start sending back images, and they're going to start publishing them shortly after the first of the year.
Good power going to the system because we're on internal power right now. Yep. And then over the next day or so, we're going to do a mid-course correction where we make sure we're in the right way to get to L2, about 1 million miles from Earth. And then over the next days, we're going to be deploying our high gain antenna, which is about as, I mean, if you were watching the video just now, you saw it as we were going away from the space vehicle. It's about as round as I am tall.
Oh, wow.
And that's just to get down the amount of data that Ami and other folks talked about earlier, back down to the ground.
And how much data are we talking about?
So we're talking about 1 terabyte of data a day from L2. So the way that I like to think about that is it's like 1 million songs that we're streaming from 1 million miles away every single day for the lifetime of Roman.
Oh my goodness.
Yeah.
Now, the team of engineers who are responsible for designing and building the spacecraft are actually watching this unfold right now. What are they looking for?
So like you said, the folks that designed, built, and integrated Roman are actually sitting on console right now and just paying attention to every little detail about Roman. I mean, there's thermal engineers that are looking at all the temperatures. There's folks in making sure the deployments are going okay. There's folks that are making sure the communications are working. And so there's just a whole crew of folks here on campus at Kennedy and up in Greenbelt and all over the country that are actually monitoring Roman as it goes to L2.
And this is kind of their first look because some of this instrumentation actually hasn't even been used or tested since it was first in testing before it was ever even integrated or put into fairings or put on a rocket.
Correct. The last time we've really turned the instruments all the way on was back when we did thermal vac months ago.
Oh my goodness.
Yeah.
And so we're going to be going through a period of what's called scientific commissioning, which is kind of that official handover from the engineering team who's doing the checkouts to the science team. Tell us a little bit about timeline and what does that look like?
Yeah, so we're going to be checking out Roman for about a month.
Yeah, this one's not going out into deep space, but
all the pointing right, and then we get into
it's the largest telescope.
That's where we're really checking out the
largest view of a telescope that they've ever made.
Handover from engineering to science, which is
the science team. Hubble is really good at looking at one point. This one's going to be able to do a much wider image.
So Jeremy, thank you so much for being here. Congratulations.
Not just a single point. It can focus in on a single point, but it also gives you a wider view.
I'm sure that if these folks also had something that Jeremy was wearing to track their heart rate, there would also be a spike.
Go ahead and mute that off. Xbox, I appreciate you coming out. You're the only one that we have. Nope. Well, let's see. It's showing 3 people now. Over. You're over on Twitch now too. Sorry about it being so early. I know a lot of people aren't up. Like I said, as soon as I get off, these videos will be posted on Twitch and YouTube. So people can go back and watch it later on if they want to. You can also go to, hold on, that's them talking in my ears bugging me. You can also go to either NASA's website or X, SpaceX's thing. They'll have a video. They'll have this video up once it completes, and as well as me. Appreciate everybody coming out. And the next time I stream rockets and stuff, hopefully will be in about 2 weeks, which will be Starship Mission 14. Going to be really interesting. They're not going to catch the rocket or booster. They said they were, and now they're saying they're not. We'll see. Brain fart. Oh, but it will be the first time they're going to actually launch 20-something satellites. The new Gen 3 satellites for Starlink on that mission. And these will actually stay up there. These will actually go up and be in orbit. In fact, this will be the first true orbiting starship. They haven't. We still haven't completed one complete orbit yet. They will on this one, though. In fact, they'll do several of them to get it back around to where it needs to be to come back in. I believe it's all going to come down into the Gulf. Yeah, the Gulf of Mexico, but they're not going to catch it. They're not supposed to. We'll see how it goes. But again, everybody, thanks for coming out. Thanks for watching. And we will see y'all all next time.
10, 9, ignition sequence starts. 6, 5, 3, 2, 1, 0. All engine running. We have a liftoff, 32 minutes past the hour. Liftoff on Apollo 11. Power clear. Plus 30 seconds.
11, 10, 9, 8. Ignition sequence has started. 6, 5, 4, 3, 2, 1, 0. We have commit and we have liftoff at 2:13. The Saturn V building up to 7.6 million pounds of thrust, and it has cleared the tower.